Okay, thank you. This is part 4, and we would have looked at the importance of this here, and specifically the importance of the pH in the stomach as designed by a designer to be acidic, pH 1 or 2, to digest the meats into polypeptides, and then it gets down into amino acids which get absorbed here, go to the liver for whatever. The plant-based product, generally glucose and fructose molecules, gets here without having to be digested here. It just passes here, 30 minutes for the most, based on what type of intake it is. If it is just refined carbs, it just gets through here very quickly, gets to the small intestine. If it is carbs in the starchy form, in the cellulose form, with fiber form, it spends a little time here because there will be some acidic creation. When fiber gets in, it irritates the lining of your stomach walls and cause acid to be released. Same thing as alcohol. But at the end of the day, plants would lead to glucose. Fructose molecules get into the liver. The liver decides that glucose goes to the blood, fine. It, it does store a little bit of glucose as fats, but fructose, it would hold on to it and metabolize it itself, leading for it to become glucose and stores generally it as fat, with of course things that has to be excreted into the bile. Things like uric acid should go into the bile, but uric acid might end up into the blood and then get excreted out by the kidney. Should Okay, now we are now into in the blood. So you eat to get something into your stomach, mainly animals. You eat animals to get into your stomach with the intent that it gives you the amino acids and fatty acids, vitamins and minerals, which gets into the liver. The liver, being similar to our water treatment plant, does clean out what needs to be cleaned, dump what has to be dumped into the bile, sends everything else into the copper pipes, which we call the blood system. In the copper pipes here, you have all these particles, amino acids, glucose. So that's like many amino acids, glucose, and then if the amino acids were combined by some organ, for example the pancreas, when it combines amino acids to make insulin, we don't call it a protein, we call it a hormone, but it's a protein that would be floating in the blood, going to do its job. And there are many other things floating along into the blood, and those things goes into the copper pipe with the intent to get to an organ. Maybe they are directed to go to an organ, so they are going to an organ. Now when they go to the organ, is the tissues they are targeting, the tissues of the organ. The cells actually is where they are trying to get, so that's where the capillaries and those small vessels go directly into the cells. Now if those things happen, the organ is just the community, and so the piping in the community to get the water, the copper piping in the community to get the water, has to be well understood. So right now there is no detail of piping here, so let me just bring in some pipes into the from the main pipe to go to the community, which is your organs. So you would see little branches of pipes going to multiple places, and these branches goes all over the place to get to every cell, and this is multiple of for the community. Think about your community. This is what is happening here inside every organ. Multiple pipes, copper pipes, are going to be placed from the main pipe that enters the organ to get to every cell in the community. Now this is important to understand and note, because at the end of the day, the community, which is the organ, does not bother itself. It is the cells, it is serving. So at the end of the day, when you think about it, the whole prospect here is to get these little things called blood to flow in smaller concentrated copper pipes with smaller concentrated amount of glucose, amino acids, whatever else that is in the blood, to come in here drip by drip by drip. It's a control mechanism to get these things dripping, like drip irrigation, into the cells. Of course, getting into the cells is still not the target. It is the target for these things to drip slowly into the mitochondria. The mitochondria has a way of eating these things, and when it eats it, so for example it eats glucose, and then it gives out carbon dioxide and water as waste, but it makes ATP on this end here. ATP is the energy we use. So the target from here again to here, so this is food, and this is nutrients into the cell, and it is molecular nutrients eaten by the mitochondria to give us A, T, P, and byproducts. Now let's look at what is happening inside the cells. So inside the cell, the entry is a pipe, a chromium and vanadium pipette that has to be open. The tap has to be open, and that is generally, if we look at glucose, the tap is being opened by insulin, so the glucose could trickling into the pipe, into the cell membrane here. This is the cell. Inside the cell has the residence, 500 residence minimum, apart from red blood cells. Tissue cells, we're speaking about hearts, organs, lungs, liver. These cells has mitochondria, which are the residents. This little red thing, brown one here, this one here, this one here, this one here. All these are mitochondria of different type, different functions. So nobody in the house is exactly the same. You know, you live in your house with your brother and he's totally different to you, and you live in your house with your sister and she's totally different, but then you have two of the same type. So the 500 residents in this one house, because we came from the community and now we are into the house, they are going to take the glucose and they are going to consume the glucose and make mitochondria waste, that's CO2 and water, and they would make the useful thing called ATP. Now this green goo that they are swimming in is a matter of waste and also a matter of food. The waste now has to come out through the excretory side of the excretory pipes of the cell, and this excretory side has to go into the lymphatic, it drains into the lymphatic system throughout the body, and this lymphatic system ultimately makes it to the kidney, where you get the kidney pulling out lymphatic waste and excreting it in the urine. Now all this sound fancy and all these things sounds quite simple from the descriptive perspective, but it is when this lymphatic waste here start backing up and this becomes closed or backed up, and you have a buildup of waste here, that you have the mitochondria suffocating in their own waste, and yet for all you have the pipe pushing in more glucose. So you have more glucose being pushed inside here because we are doing things like taking insulin to just open the pipe wider and wider and wider. Then we might try to force the pipe, which is made of chromium and vanadium, and break the pipe head, which causes metabolic issues for intake now. But the fact is, if we are pushing in here and they are slowing down their processes, as the mitochondria, because they are swimming in their own SHI, you know, the last T, and this here is blocked, we also have a problem. So how to help to move these things here, to get things moving here? That's a question that, you know, you may learn from the natural part, that you do things like rebounding, physical exercise, but from the medical system you learn that an increase in butyrate, butyric acid, butter, those things help with the lymphatic system, because actually the lymphatic system absorb a lot of these things, the butyrate, acinate, propionate, from the colonic cells, and that's why it was found when you use fiber, the colon converts the fiber to butyrate and propionate acetate. That's where it happens. But if you consume things like butter, coconut oils, those things, one, you are slowing down the passage of glucose here. It's not that it would never have, because these things, any fats, any protein becomes glucose when the liver decides to do it, it's gonna convert it to glucose. But the amount that would be trickling now is much less, because you're not putting glucose in your mouth, and the less amount of glucose is a new pipe that is opening. It's the pipe over here, the golden pipe, which is the pipe that might take in fatty acids, giving the body, once the body gets back chromium and vanadium and other nutrients, amino acids, in time this pipe head could be repaired, but you have to run on the next pipe here, the backup pipe that would feed the cell, or that would bring nutrients to the cell. And so the mitochondria could flip from burning all this carbon and flip from making all this waste, carbon dioxide and water, which is quite acidic. And so this here gets a little break, but you cannot say here gets a little break and not focus on the kidney. You have to focus that the kidney needs to get rid of glucose. The same problem up here is the same problem affecting the kidney. There is no difference. This could be actually a kidney cell, this could be a liver cell, this could be a heart cell, this could be any cell in the tissue. They are all affected by the overly abundant amount of glucose in the bloodstream coming to them over and over and over. And how we get rid of this? By, of course, one, reducing the amount of glucose we take into our bodies, and increasing the amount of nutrients that we put in our mouth. Now you might say, but what does that mean? Well, it means that you have to understand nutrients. Nutrients doesn't come from glucose. Nutrients comes from fatty acids, amino acids, and minerals. And you have to ask yourself whether you're going to be a plant-based eater. You have to supplement with a lot of these things: amino acids, minerals, fatty acids. And if you're interested in learning about that, I could sit and give you a dedicated protocol. It would be very costly to follow a plant-based diet and get your nutrients up to par. However, if you are open towards an animal-based diet, you would still have to note that you eat your, if you are so desirous of eating carbohydrates or plants, which is just two things we eat. If you eat plants, you eat it in the morning when the sun is out so that the mitochondria gets activated. You could eat it in the morning, but when you eat in the evening, you eat your meat by itself. Eating meat together with anything else leads to this here not digesting the meat properly. So meat eaters are also falling into the trap of eating other things with their meat. Again, go back to video number 1 and you'll have a full description of why the stomach acidity is the trick or the key in healing or in supplying nutrients to the liver. It's supplying nutrients to the liver. And then of course, once the liver has nutrients, it could detoxify. Once the liver has nutrients, it could send to the copper pipes. Once the copper pipe has nutrients, it will send it to the tissues. Once the tissues have nutrients, they could heal. Once the tissues have nutrients, they could send to the cells. Once the cells have nutrients, it would send it to ultimately to the mitochondria. Once the mitochondria is getting good nutrients and not just an overconsumption or flooding amount of glucose, it could heal itself and it could perform its duty better. And of course, the kidneys is part of the whole system. Thank you for viewing. Please feel free to reach out with the description in the link in my video.